Every piece they cut off, you see a sample up here where you can do different things, you can do it round, you can do all the shapes that they need. And the more complicated it gets, the longer it takes, of course, to do it manually. With this machine you do it automatically and precise every single time.
Maskinen der kører kun 2 timer på en arbejdsdag, fordi det kan have større produktion i højre del. Så den har rigelig kapacitet i den maskine her, til at kunne klare flere folk. Så cirka 2 timer om dagen, der kan vi nøjes med at køre i øjeblikket. Det har så stor produktion. Så kører vi huller og fejl og alt muligt. Alt hvad der er arbejde, det laver jeg herude. Forbruger huller til montage, så det er planlagt.
On the detailed drawings, they have all the specifications for each piece. So it does the holes, it do the cuts, do everything included in it. So we just stacked, ready for production. You can actually stack here. You do them round. You even do them round. So that look at the drawing, it's 60 centimeters in diameter. That moves according, so when the wood moves, that moves with it. So you can do all those different shapes.
Now it's the wood.
Huh?
Now it's the wood. It's like a wood CNC.
And it works for about 2 hours a day for a normal production as it looks at the moment. Når I får maximum, hvad kører det så cirka? So at maximum 6 hours a day, at that moment it's very low, it's about 2 hours a day. So it makes all the capacity for the wood they need.
Første en kassebrød koster kun 350 kroner plus moms.
Den tag her, de der skilt der, vi har monteret nogle brædder på, som man har dårlige erfaringer med. Det er været fra materialer på det, der var dårligt. Og så har bygherren valgt at få en anden plade på, så vi har travlbrædder i det. Det var rigtig monteret her på. Derfor er det vildt at tage herinde, hvor vi rykker plader af og monterer en ny plade.
Case they're doing at the moment, they have found out because of these other projects, that there's a floor that facing the windbreak layers. So what they've done is that they move all the elements into here because the client wants a good quality. So they take it all off, really, basically, and then replace it with the new material they have been on with the client. He doesn't dare. That's the reason why he wants to take a little extra to replace the whole construction. If you saw the picture of the project, it is rather complicated. So if you decide not to change that and go to the building site to change it, first of all, it is in height, it is finished, so it is a lot more complicated to replace there than here. We're wood-breaking layers, because they have some bad here. What you see here with the element here, if you look out here, what is actually in between here is the load-bearing concrete wall. That is the separation between the different apartments. So what you will see here is also you have a tolerance about 15 millimeters to each side. You know that it will grow a bit on site. But to prevent this, they have this little special invention here, where you got the damp-proof membrane filled up with insulation. So when you come to the building site and fit it in, that will, fill it out the gap in between them, and make a sealing between them.
What, this is the floor?
No, this is a wall. It's a wall. We just have put it down.
And here you have the
It's going to be standing up like that.
So this is seen from the top?
Yes.
Ah, okay.
But then you have here the concrete wall, and then you have the next oil.
We rise that up, so
Yeah,
you'll see that the concrete slab is what you're standing on, right?
And then you have
And there will be, a big wall, concrete. It's a separation between two apartments.
And then close again.
Yeah, in against, yeah. At the midway, you put angle brackets So the bracket will be fitted to the concrete. So we come to the building site, where you lift up the element, and you can drill into the concrete and fix the element. And then you fill the gap just as you saw before, with insulation, and then close it. You do that on site. And also that's because of the tolerance you have. You know there will always be a difference. You can never... Remember when we talked about other contractors? You see, another contractor will finish the job here. But before he finished that, he needs to fix something into the elements. But if they didn't talk together, they wouldn't have found out this. They talk together. So eventually what happens on the building site is that you put on by 30 centimeters a distance exactly. So you can fit your surface on top of that. But that will be done on site. But they need something to fix it to. And that's been prepared here. It has nothing to do with the element itself, it has to do with the finished surface. Another contractor. On the other side, interior of the building, you need to fix the radiators, sinks, equipment of any sort. You need exactly the same solution, so they have the same on the other side.
Fordi de har brugt hendes mega hit Killing Me Softly som et citat i en politisk kampagne imod koncert. Så derfor så bliver der altså ikke nogen koncert. Det gør der til gengæld med Danske Mø, som altså stadig holder fast og siger, foden i jorden, jeg holder den her koncert. Og lige nu kan du faktisk også høre fra Mø, nemlig sammen med Major Lazer og DJ Snake. Det her, det er lige.
Og så kan man sige sådan noget med, at vi lader pindene køre igennem, ikke for at holde bugen. Fordi hvis det er en af stumper, så er de jo lige. Altså man ligesom skal prøve på hele tiden at prøve at holde bugen. Det er noget, det vil ret meget med på at prøve det.
The architectural idea about it is that it's going to be round. If you had cut in small pieces and put it on, it will be angled all the way around. And when you had to finish up that you can actually see that on distance from the building. So to prevent that, of course, you have to go all the way through. So the process is when you fit them, that you keep that curvature on site. So the mounting groove, the instrumentation, is very important that they keep that alignment all the way around. And this is the way they can do that.
Har ude på hundlæggerne, hvor jeg har taget toppen her. Den er jo saden hernede. Og så har fræseren kørt i det spor. Så når jeg sætter den herop, så bliver den rundt.
What he tells here is, we talk about use of the material. We have some waste. In this case, they minimize the waste, and that meant, look over here, all of you. You see this straight line, that is a straight piece of wood. Up here, it is the thickest original. And then you cut away until you get nothing, see? Yes. But the part that you take away, you turn it down here, and that's what you got here. You see that part is coming from up here. So you minimize the waste.
This bottom.
Yeah.
Okay, yeah.
Yeah, it's smart down here. Taken away from this piece is just assembled on the other side. When they cut it, make this little drill here to make sure it's been sent. So when you put those on top of each other, you know it is the same there, right? But the saw do that automatically. The window sill in the element. This is not what's visible, but it's prepared in the element. So when you have the window, it is the curvature as well.
Yeah.
When you start up the assembly, it is just like a Lego set. All the pieces is ready here, not just like you saw in the concrete factory. It's all ready. So what you only have to do is that if you look at the drawing, also like what they did at the concrete factory, But now we got other measurements because he has to put this together in such a way that it's going to be eventually, when you get over here, turned around. So he makes this ready. He fits everything according to the drawing that they did as the designers at the office, and it moves on to the next station. Yeah? And that is the stations we talk about when we have in a working process. So what happens first? This is what we do first. And then we go to the next station to see what they do next.
But how they can cut it so thin and it doesn't break?
The machine. It's too soft.
That's why your tools have to be sharp.
Yeah.
But wouldn't be this a problem?
No, I don't think so.
It's not load bearing. It is more to keep the structure, to keep it so you have something to fit it into. It's not load bearing. It's not stabilizing. It's just a part of the structure. But of course, you're right. If you're something that have to be, then you have a problem, and then you wouldn't use it. But for stuff like this, you can. Every process of here, have you used the right nails? Is that the right kind of wood? Is that the depth of membrane? Is it placed in the right layer? You know, everything has to be checked up, because if you don't do this, it is expensive to rip off, because you have to throw this away. It's been penetrated. You know, do it the right way first, and that's what you check up. Have you done it that way? And then you move on all the way through the production. And next station, they have something else to check up. And we can look at that when we go on to the next station.
It's not gonna fall? Or the idea is to fall?
This has to do with health and safety we talk about in production lines, because we don't want to hurt people. And this is very heavy, and they can be a lot more heavy than this small element, because of course you may be able to do it to paper. But what the principle are is that it is with the inside upwards when you start up the element, and you move it on over the rollers. And the idea is that then you can, by hydraulics, lift it up. And it's made such way so when you lift this up at the same time, the arms is placed differently, so you can just, you know, take that down, and then it turns around the element without even harm anything and anybody. It's able to do up to 13 meters of elements
13?
in this way, yeah, because they have a system at the other side which is completely matching here. They can have
an
an
element all the way.
all the way, yeah.
3 meter og 80 i højden.
3 meters 80 in the height.
Værsgo, fortsæt.
Det var pausen for i dag. The curvature on the other direction, because we are in the inside now.
Ah, this is what they put. This is the
But of the building.
Yes.
The part of the story that will go on when you start the mounting phase. But to give the story of what he's talking about, you see the whole building.
Yeah.
Many of these individual departments have an element with the same shape, with the same holes for windows and doors. They are the same. So he could have 50 of the same variation, you see? But because the function of the different rooms is different, some of them need safety glass. Other ones will have to be, because it's facing south, sun area.
The windows will be
So
unique.
when they fit these specific windows for these 50 elements, they will be unique, and they can only be fitting where it is supposed. For example, over here. So the same element can be used here, 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 here. But when the window is placed, it can only be used there, not here. So the quality assurance is 58 different variations you got of windows. 58. We call that planning. The design is made such way, actually quite clever. It has to be 2 layers of plasterboard.
Yeah.
It has to be MDF that sits in this drill alignment all the way around the window. And it's made that way so when you're on the building site, this sits
You can fix it.
here in the
on that
production.
one, yeah.
But it's just 2 screws, so you take them out and you just move it where you need it, the day when you mount it. So it's very fast assembly.
You don't need to cut any more pieces.
You know, and fast means cheaper.
Again.
Again.
Og plastik, det er med ud, det de skal bruge for at komme ned til gulvet. Lidt mindre plastik foroven, for det er meget tættere på loftet. Der er kun en lille pilhøjde. Hernede der har du 14 cm gulv, du skal ned og til. Der er plastik i siderne, op imod betonvæggen. Det er indeni. Det er klar til at fuge det hele, når det ankommer til pladsen.
The element is such finished that when you move this to the building site, you need more space to the floor because there will be fitted some sort of a construction on top of this. So of course you need a longer piece of plastic to seal to the floor than you need to the ceiling. But it is prepared so it is just to rip it off and then seal it on site. Yeah. Also to the side.
And what are these?
That's to keep in the insulation so it doesn't come out. When on the building site it's very windy, you know. If that fall out, yeah, it's time. You know, it's the time to fix it that costs money, and it's cheap and fast to do this, and you ensure that it doesn't flow away, even in the transportation of it. Yeah.
Det er kun, det er fordi det er 10-15 om ugen. Alt efter størrelse. Nu er der nogle små elementer, så laver vi 15, og når de store er, så laver vi kun 10.
The big elements, like these, approximate about 11-12. When they are smaller, it's about 15.
A day?
No.
On the side? Det er byggepladsen, hvad bruger den til?
Nå, her.
For det er cirka.
De bruger til 10 uger.
For hele. 10 weeks.
Uden der er ikke gift med i.
The whole project of the mounting of the element is 10 weeks. 10 weeks.
Yeah, but here, how long does it take one element to do?
That's what I said.
Here.
In the factory.
How much time?
Yeah, then
So divide 7 by 15, so less than 1 day. Some hours.
Yeah.
And how many workers do you have?
Hvor mange hours er det?
Vi er 12
12, 20?
12.
12.
Sådan et element som det her, det står til 1,2 time per kvadratmeter. Det er produktionstiden. Det er den tid, de må bruge. 1,2 time. Plus montagevinduet.
The production time for an element like this is 1.2 hours for each square meter. Approximately.
that's what they get paid for.
That's what they get paid for.
And what's the price for 1 square meter?
Hvad er prisen for 1 kvadratmeter på den her element?
Det her det er lige omkring 1000.
1,000 crowns approximately.
More than the concrete.
Yeah, but it's,
But the concrete
it's
was
a different quality.
Organic.
Yeah, because we were talking about
They also
the
round
ugly
the
stuff.
base.
One thing which is important to say according to prices is because of the insulation. It is very high performance insulation with lambda value. And that makes it a higher price. So the
It's really
heat consumption in a building like this is a lot lower than it would be in a normal house.
We all the time use this insulation.
What's the lambda value?
How much time to
0.
09.
No.
0.9.
0.09 on each project. What is the U by
0.9?
0.039.
No. That's a flammable.
0.09.
That's not allowed. Concrete is not flammable. That's why it's used there.
No.
Vi spurgte til UBD. 009. I don't have.
0.09
Yeah.
is the U-value of each element. That's pretty low.
Det er på grund af konstruktionen, ikke? Vi hele tiden sørger for, at
They ensure it with the quality assurance that it is, important that the installation is done the right way. So if you look at it, it's firmly done all the way around, and they spend, much of their time to do that accurately. And that's why they can keep down their U-value as well.
Because cold bridges.
Also the cold bridges.
og der vi gav pris på, der blev spurgt efter, om vi kunne lægge forskalling udvendigt også, for at komme ned på 0,7.
They will ask at the tender. Whether they can do an extra addition, so they can actually take down the U-value to 0.07. But they didn't do it.
They put what, another button?
Another one back here,
The same size or smaller?
same size, on the other side,
Then it will
in the middle. So you didn't have flanking like that, but you had here. So that construction would take it down to 0.07.